Hello. Again, let me continue in discussing my assigned topic in the MTAP-DepEd NCR Summer Inset that for grade 10 that focuses on circle. So at this point, let's focus on problem number 11, and it says here that there are three equal circles which are externally tangent to each other so that each circle touches the other two. A belt that is placed around these three circles is 50 feet in length. Find, in terms of pi, the radius of each of these circles. Okay, remember, it was mentioned that there are three equal circles externally tangent to each other, but each circle touches the other two, meaning they are not aligned to each other. Okay, so because, again, it was mentioned, one circle touches the other two, so as shown. Okay, now, also, it was mentioned that there is a belt wrapped around this figure, which is 50 feet in length, as shown. Okay, now, so since the three circles are equal, of course, the radius are also equal. So if I'm going to connect their centers, I can form a triangle. And what specific triangle is formed? Correct. This is an equilateral triangle. Okay, so since this is R, this is also R, so one length is 2R. Okay, so since equilateral triangle yan, so we can say that this angle here is 60 degrees. Okay, now, we also know the fact that from the center, okay, so this is tangent here, this side here is tangent. So, we know that from the center, if I'm going to connect a radius here, that's perpendicular to this segment, as shown. Okay, so therefore, this is 90. Okay, if I'm going to do the same in the two remaining arcs, okay, so makakreate ako ng ganyan. And we know that they are parallel. Okay, so since parallel yan, we can say that this is 90, this is 90. So therefore, this remaining angle theta here is, correct, 120. So since 90 plus 90, 180 and plus 60, 240. So 360 minus 240, that will give me 120, which is the measure of this central angle theta. Okay, now remember, our goal here is to express the radius r in terms of pi. Okay, so how are we going to do that? Okay, can you tell me what's the relationship of this segment here to this segment here and to this third segment here? Correct, they are also equal. So since parallel yan, equilateral triangle to, equal yan. So therefore, equal din tong remaining sides of the rectangle form. How about the three arcs form? Correct. So equal din yan. So since this is theta, same reason, 90, 90, 60, 90, 90, 60. So therefore, the remaining two arc central angle here is also equal to 120. Okay, so equal yung arc. Now, we know that the length of the belt here, which is equal to 50, is actually 3 times the length of this rectangle. Agree? Plus 3 times the arc length. Okay. Now, and how are we going to get the arc length? The arc length is actually given by S equals the product of the radius and the angle theta. Take note that this theta here should be expressed in terms of radian. Okay, so since our angle is 120, as you mentioned earlier, so we're going to use theta, which is 2 pi over 3 radians. Okay, so let's just follow the formula. So the length of the belt is 50, which is equal to thrice the side of the rectangle, which is 2 pi, plus 3 times the arc length. And our arc length, again, remember, which is the product of the radius and the central angle in terms of theta, which radian, which is 2 pi over 3. We can easily cancel this one. So therefore, we have 50 equals r times 6 plus 2 pi. So I already factored out r here. And obviously, if I'm going to solve for r, so we simply divide it. So r is actually equal to, divided by 2 yan, 25 over 3 plus pi. Okay? So that's it. We already expressed the radius in terms of pi. Okay, I hope you understand that. So for more questions, don't hesitate to reach me on my Facebook account or email me at markvidaldo22@yahoo.com. So until next time, peace.